Hello everyone. In this video, I shall be introducing COVID analytics and how to use it. COVID analytics is a coronavirus epidemic monitoring and modeling app that I created in Mathematica. Anyone and everyone can go ahead and use it freely, as I've made it available on Mathematica's Computational Intelligence Cloud Deployment platform. Just go to the host URL above here, which I'll give out in the comment area for an automatic launch. But for the remainder of the video, I'll be presenting COVID analytics natively from within Mathematica software. Okay. Now, as you can see, the app itself has two areas. The left-hand side here is where you get the display, the graph, and the numerical outputs. The right-hand side here is where you have the control panel. The control panel itself is separated into top half and bottom half. The top half controls the data source. Here it automatically loads the data for the world COVID-19 cases, but you have other countries that you can load up as well. Then you have the various model parameters. Altogether, there'll be the basic parameters of the model. There are 5 of them, and there are 3 additional parameters. So at most, you have 8 model parameters that you can fiddle around with to calibrate with the real world data. Now, the bottom right-hand side is where you control what appears on the left, as well as their appearance. You notice that there are actually 3 little blocks. So it separately controls 3 different areas. So let me hide them. Okay, so there is the top panel here. This is where you show the actual data versus the model output. Okay. For the data, that covers the total cases as well as the total death for each location. In this case, again, it's the world. Okay. The second panel here has to do with the error function. Basically, it's how well the model is fitting real data. As it currently stands, would be this is the error of the current model is in the middle here. And to the right and to the left is what happens to the error function as you tweak the model parameters to the right and to the left. For example, this is the first parameter, this is second, third, fourth, and fifth. So 1, 2, 3, 4, 5. If I increase the parameters, say for example, this one, which I'll discuss in details in later part, if I increase this to the right, it's not going to improve the model very much. In fact, it's going to make it worse. So if I move it to the right, you'll see that it increases the error. Okay. So let's go back to the original. Right. And I'll show how it works a little bit in detail. And finally, the third panel shows once you have calibrated the model parameter, this is the projection into the future. So the future scenario or going back to the past. So this is comparing the real data versus the model data. So for example, today we're standing at day 127 of the epidemics, and the total case data is 3.5 million, and the model is calibrated value is about 368,000, so about a little bit over 100,000 cases off, and total death of 250. It predicts about 253, so off by about 3,000 cases. Okay, and if you click here, it also shows the model parameters, the value, the model parameters, and I'll discuss them in details later. Right. So let's get back to the key display, which I think is this area here. Right. The way this app works is again, it's an interactive software that allows you to play with the model calibration, and the 2 parameters here deals with the initial size of the population and the initial size of the infectious population. It expresses a power of 10. For example, if I put in 6 over here, it means we are modeling a total population of 10 to the 6 or million people. And if I put -5, or let's say -4 over here, that means 10 to the -4, or 1 out of every 10,000 is the initial infected portion. Okay. This parameter here is called infectivity. It's basically the rate of transmission. It tells you how fast the infected people spread disease to the susceptible or uninfected people. And this parameter here is called dissipation. It tells you how fast the infected or infectious population, who are also disease carrier and therefore spreading disease, how fast this group dissipates. So that's how fast they stop becoming spreader of disease. Now, of course, people who are infected can stop spreading disease in one of two ways. One, they can recover fully and become immune, or two, they can die. And the proportion of fatality is controlled by this third parameter here. Okay. The way the Mathematica interactive panel works is if you click on the right-hand side here, maybe you can actually enter the value manually. Just click in here and enter the value with the keyboard. But you can also just go back to the original here. Just use the slider. Right. Now, automatically it loads the data for world as well as the basic set of parameters that I have prior calibrated to be fairly close to the data set. Now, if you go to other example country, for example, go to the United States, okay, and then you re-click the reset parameters, then it would also go to the set of parameters that I have tried to calibrate to be close to reality. The third country that I have manually calibrated is Thailand. So you go to Thailand and reset the parameter, then it gets to the set of parameters that I previously calibrated. Now notice two things here. Thailand here is quite interesting because it's actually outside China. It's the first country that has contracted the COVID-19. So it's a country with the longest exposure of 1,414 days. So basically 13 days after China. But the data itself, I think, is lagged by 2 days. For example, if you go to the website of the coronavirus, currently the number should read for today 2,989 because we have had one more case of contraction today. Now the data, it says 2987. That's actually 2 days old as opposed to 1 day old as indicated here. So I think the data stream that I load has cut off time. That means data from Thailand is 2 days old rather than 1 day old. Right. And this here is a little bit interesting because actually by design, the fatality parameter should not have any effect on this error, which is the error of the total number of cases. But I think there's some numerical instability because it actually, if you look at it, it's actually a difference of 0.001 of a person. Okay, so that's really nothing. In fact, if you zoom out, it comes to nothing. Okay, so that is basically the software. You can go to this cloud address, click it, and it automatically launch. Now, for other countries, I haven't done any calibration whatsoever. So if you click to the other countries, if you go to reset parameters, it will still be very far off, and you have to play around with the parameter set here. Okay, but for again, for the world, for United States and for Thailand, if you reset the parameter, it would get to be very close. Right. Now, in the next video, I'll be discussing in detail what those parameters actually mean and how they work, because this is actually based on what's called SIRD epidemic models. But in this video, I just want to introduce you to the basic layout and perhaps you can get going playing around with the software. Okay, thank you and goodbye.